Hello,
Hi.
can you guess the topic of today's lecture?
Yes, loads.
Exactly. What loads are taken in consideration in facade design engineering?
So this depends on the facade structure that is chosen.
Right.
Let's imagine having a curtain wall, for example. So curtain walls are non-structural walls, so they are non-load bearing facades.
Correct.
So the main functions of curtain walls is to create a barrier between the inside and the outside. However, you can imagine that there are external loads acting on the facade.
Like wind.
Yes, the most obvious one is wind. And we can have a wind pressure, but also wind suction.
Right.
And this wind load, together with the dead load of the facade element itself, needs to be transported to the primary structure of the building. And this is usually done with different levels of load transfer. So on the first level, we have the glazing. The wind is acting on the glazing. It's an infill element.
Let's imagine this is a curtain wall for a moment.
Yes. Let's imagine this is a curtain wall. So the wind is acting on the glazing, which is the infill element. And then this load has to be transferred to the secondary structure, which mainly is the support of the glazing. Can be
a frame, for instance, mullions.
Yes, mullions, transoms, and so on. And from the secondary structure, the load needs to be transferred to the primary structure, which is the load-bearing structure of the building.
Which could be a steel frame, a timber frame, we don't know, it changes, of course.
Yes, it can be different structural systems. And the main task of this system is to take all the loads that are acting inside the building down to the foundation.
So is there any other force, stress that is considered when designing the components of a facade?
Yes, so there are several other ones. So I see you are leaning now against the glazing.
Yes.
So this is kind of a horizontal live load. It also needs to be respected and to be transferred to the primary structure. There can be impact loads. And we also have stresses that are induced, for example, by settlements of the buildings or deformations, temperature changes, or volume changes.
Volume, for instance, because of the cavity inside the glass, the insulated glazing?
Yes, so I think you are talking about the climatic loads in insulated glazing. Yes, this is a very important load that needs to be respected during the design of insulated glass. So insulating glazing means that we have two glass panes and a cavity in between. And in this cavity, we have a gas. And the volume of this gas can change.
Depending on temperature or pressure.
Exactly. And due to this volume change, we introduce stresses in the glass and they need to be respected during the design.
Interesting. And there are many more actions and forces, but these for sure are the most typical ones.
Yes.
And what if a facade is load-bearing? Changes?
Yes, it changes. So when the facade is load-bearing, then it is part of the primary structure of the building, which means that it also gets loads from the building to the facade. Yes.
Wait a minute. I know a building here that has a load-bearing facade.
Oh, interesting.
Let's have a look?
Yes.
Okay, let's go.
Thank you.
This is the building I was meaning. It's the Co-Creation Center at the Green Village at UW Delft, and I believe it's a load-bearing glass facade. But tell me, what do you think?
Yes, you are right. This is a load-bearing glass facade. Compared to the building we have been before, here the glass is also carrying the main loads, which means that the glass is also the main structure of this building. In the building before, the glass was mainly a filling element, which means that the loads acting from outside are transferred to the substructure, which then is the main structure of the building. So here it is different. And the glass also has to carry, for example, the weight of the roof.
Right, because as we can see, effectively the roof is carried by the glass facade.
Yes, exactly. And that's why we also get in-plane stress in the glass. In this case, it can be, or it's probably a compression stress because the load from the roof has to be transferred to, yes, exactly, has to be transferred vertically. And as we know, high compression stresses can lead to stability problems, which means buckling.
Buckling reminds me is the typical problem of Charlie Chaplin's stick, where he's carrying his load and stick, which is a sort of a thin component, deflects in plane.
Yes, exactly. And the longer the length or the more slender the system is, then the lower are also the buckling loads.
Interesting. And then when we detail a facade, we have to take into account tolerance and movements to avoid other stresses, right?
Yes, that's correct. So the loads I've mentioned before, they create effects in the components. They are mainly stresses or deflections. But we also can generate stresses through displacements, for example, settlements of the building, and constraints. So, yeah.
Here I also see another example, no? Because we see an overhang, and this overhang is partially shading the glass.
Yeah.
So it might be, depending on the solar radiation, that some part of the facade is heated by the sun more than another part. And this could be also a load.
That's true. We can have thermally induced stresses, which means that, at some point the glass wants to extend, and at another point it wants to contract, and then we have stresses that also can lead to failure in worst case.
So this glass facade was also designed to avoid thermal shock and these thermal loads, thermal induced stresses. Okay, I think we have all the ingredients for our week where we are gonna assess basic structural performance of the facade.